All right, we're moving on to lesson chapter 11, section 8. We're adding and subtracting radicals. This is fun. I don't know, this just brings me back to the beginning of Algebra 1. Our essential question is, can you simplify sums and differences of radicals? So let me just remind you that your mean math teacher made you memorize your perfect squares. I always take time to write down my perfect squares because I know I'm going to have to reduce and figure out what goes into what, and usually they keep them pretty simple. But if we start with example 1, and I just have 8 root 11 and 2 root 11, we're really just adding the coefficients. 8 and 2 is 10 root 11. So you have to add if they are like radicals, and you can only add the coefficients. Do not add inside of the radical. So on the next one, I have a 7 root 3, which could be added with a negative root 3. And I have a 2 root 2 and a negative 3 root 2. So not too tough. 7 root 3 minus root 3 is 6 root 3. And 2 root 2 and negative 3 root 2, well, I put in a positive, it should be minus a root 2. Because these are not like radicals, they cannot be added, so we're not going to add those. Now, sometimes you got to break things down, and that's why I wrote down my perfect squares. 2 under the radical cannot be broken down, so there's nothing I can do. But 27 and 98 can. So remember that 27 has a perfect square of 9 that goes in it. So I know this is 2 times 3 root 3, which is 6 root 3. Well, I'm going to write down my 25 root 2. And 98, just memorize this one because I see it a lot, is 49. Well, 49 is 7 root 2, 21 root 2. So let me put that over here. And remember, we can only add things that are like radicals. So 25 root 2 and negative 21 root 2 is 4 root 2. And it looks like the 6 root 3 stands alone. Great job. Oh, one other thing I wanted to talk about in this is hopefully you know your divisibility rules. These are great things to know. So I'll go over a couple of them. We know that something's divisible by 2 if it's even or ends in 0, 2, 4, 6, or 8. I know that something is divisible by 3 if the sum of the digits is divisible by 3. And that goes with 9 too. The sum of the digits has to be divisible by 9. And once you know your 2 and your 3, it makes the 6 really convenient. If the number is divisible by 2 and 3, 2 times 3 is 6. 4 is actually kind of easy if the last 2 digits is divisible by 4. So I think that's crazy. You could have like a 1 million number that ends in 24 and it's divisible by it. 5, we know that it's divisible by 5 if it ends in 0 or 5. 7, I don't know. Sometimes I think you're better off just taking the time to divide it. I don't know that this is my favorite, but cross off the last digit, double it, and subtract. Yeah, I think you just might as well take 7 and divide by that point. Moving on to 8. If the last 3 digits, so it's very similar to 4, so I'll put that in the same color. And 10 is very similar to 5, but the only last digit is 0, not 5. 11, there's a lot of 11's tricks, so maybe do a little research if you were really interested in doing that to find some more divisibility tricks on 11. But it says subtract the last digit from the number formed by the remaining digits if the new number is divisible by 11. Again, sometimes it's just easier to actually take 11 and divide it. And then the last one is 12. If the number is divisible by 3 and 4, it's kind of like 6. It is also divisible by 12.